Solving equations that are quadratic in form, Part 2. Solve the equation by making an appropriate substitution. X minus 9 times the square root x plus 14 equals 0. We're going to substitute u for an expression of x. Now, this polynomial is in quadratic form, but it's not in the standard form ax squared plus bx plus c. So we can look at the middle term, which is the square root x, and we can let u equal the square root of x. That means that u squared would equal the square root of x squared. And the square root of x squared is the same thing as x. So if I let u squared equal x and u equals the square root of x, I will have an equation in quadratic form. Since this checks out, I'll go ahead and make my appropriate substitutions. Instead of x, we'll write u squared, and instead of the square root of x, I'll write u. Now we have u squared minus 9u plus 14 equals 0. And we can factor this into two sets of binomials. I have a u in the first position of each parenthesis. Next, I'll look at my constant term, which is a 14, and list the factors of 14. So this is 1 times 14 and 2 times 7. Now I want to choose a pair that when combined will give me the middle number of negative 9. If I choose 2 and 7, I know that I can do a negative 2 minus 7 to give me a negative 9. And this will check out because a negative 2 times negative 7 will give me that positive 14. So I'll put a minus 2 in one parenthesis and a minus 7 in the other. Next, we'll set each factor equal to 0 and solve for u. In the first equation, I'll add 2 to both sides, and I'm left with u equals 2. In the second equation, we'll add 7 to both sides, and we're left with u equals 7. Lastly, I want to replace the u with the square root of x. So I have the square root of x equals 2 and the square root of x equals 7. I want to isolate the x or undo the square root bar, so I'll square both sides of both equations. And in my first equation, I'm left with x equals 2 squared, which is 4. And in my second equation, I'm left with x equals 7 squared, which is 49. So my solutions are x equals 4 and x equals 49.